Welcome to Information Visualization, Week 1. Before I get started, I would like to acknowledge that the course materials draw liberally, with permission, from the following sources. One source is the same class taught by Professor Jamie Snyder here at the iSchool. The other main source is the instructor resources from our textbooks. So what is information visualization? Well, there could be many different definitions, but one simple definition could be it is a graphical representation of information or data. Or in other words, it represents data with graphics or images that allows us to explore our dataset through visual patterns. And here are some examples. So this is not the first time that the iSchool offer this class. And students who took the class in previous offerings have created many appealing information visualizations. And here are some examples. Hopefully, towards the end of this semester, you all can create these appealing information visualizations yourself based on what you learn from this class. So for this week, we're just to start this class by exploring 4 concepts. The first is, what is a visualization? Related to that, what's visual thinking and visual encoding? And finally, I would suggest that visualization is more than a pretty picture with graphics, but it's something that should tell a clear story. Okay, to start with, what is information visualization? Again, our simple working definition is that it is a graphical representation of data or information that allows us to gain insights from the underlying dataset. So is this a visualization? Well, each dot might represent, let's say, a particular student in a class. So in this case, it is a visualization. Is this a visualization? Well, clearly, there are 2 different types of dots, one in orange, one in blue. So maybe, this could be, the number of undergraduate students and graduate students in a particular department. Is this a visualization? Well, the dots seem to be randomly displayed, especially the left-hand side of this graph. And obviously, the dots have different sizes, but I don't really know what does that mean. So I'm not sure this is really a visualization. How about this one? Well, all the dots are aligned greatly, and we're using different colors. So maybe that's, each color represent, let's say, a particular type of students in a particular class. And maybe every column represent, say, a particular group of students in this class. This is interesting. Now we have the x-axis with 1 to 12. So maybe each column represents a particular month. So this could be a time theory data. And perhaps each column represents the proportion of some kind of events that occur in that month. Finally, is this a visualization? Probably not. I mean, it's just a list of numbers. It's not even a graphical representation. Okay, so we've talked about what is information visualization. Now I wanted to talk about what is visual thinking, which is a critical concept for creating effective visualization. The first thing I want to talk about is patterns. Well, first of all, we need to know that human beings, we attend selectively, meaning that we don't attend to everything we see. So for example, you see this busy graph with so many people in this graph, and it's really hard to pay attention to every human being depicted in this graph, right? Again, it's really hard to detect any patterns in this case. So in order to have effective visualization, one of the goals is to make the important information or meaningful information salient in our visualization. So these aspects of the data set stand out in our visualization. So how do we do that? How do we make these important or meaningful information from our data set stand out in our data set? Well, one thing we can rely on is something called pre-attentive attributes. By that I mean attributes that we don't need to focus our attention. So, these are things like length, width, orientation. But how do we define pre-attentive attributes? Well, if we can perceive or identify an attribute within 200 to 250 milliseconds, we consider that as a pre-attentive attribute. And you may ask why? I mean, why 200 or 250 milliseconds? Well, that's because usually our eye movement takes about 200 milliseconds. So if we can recognize something even without eye movement, that means it's very quick. It's considered pre-attentive. So here's a list of pre-attentive attributes. So on the top row from the left, we have length, right? You can immediately see that one line is shorter than the other, 3 lines. The next is width. Again, one line is much wider or thicker than the other 3 lines. The third is orientation, right? You see that one line is not vertical, there's an angle. The fourth is size. Again, you can see that there's one circle that's much bigger than the other circles. And now the second row, the bottom row from the left, we have shape, right? You see that there's a square that stands out amongst a group of lines. Next, we have curvature. That means an object that has certain curve. So for example, here you see that there's a line which is not curved amongst a group of circles or curved objects. The next is enclosure, meaning that, so in this case, one circle is enclosed within another circle. And the last is blurred. You see that the dot in the middle is blurred, and this is another pre-attentive attribute. And you might ask, okay, so why do we care about these pre-attentive attributes? And the reason that these things matter is because, again, we wanted to present the most important or meaningful information from our data set in a way that they can be perceived almost immediately, right? Or in other words, we should map the most important variables or information from our data set to these pre-attentive attributes so that they can be perceived almost immediately. They can stand out in our visualization. Which leads to the next topic, which is how do we map from the variables in our data set to these perceptual attributes, something we call visual encoding. So you would encode or map information to these visual properties or attributes. And here you see a matrix or a table where each column, starting from the second column, represent a particular visual attribute. So these are position, length, orientation, size, and color. And every row, you see a particular pattern or trend that we're trying to present in our visualization. So for instance, the second row from the top, where we wanted to present the increasing trend. And you can see that for position, it's quite clear, the dots are going upwards. It's an increase. Same as length, the lines are getting longer and longer. And also with the directional orientation, you see an upside slope. And same with size, the bar gets taller. The color is not so clear. I mean, it seems like it's getting darker, but it's more difficult to perceive that immediately. And you can also take a look at the other trends. Decrease, repeated combination ups and downs. Outliers. For outliers position, it's very clear that there's one dot that's kind of far from the others, right? That's the outlier. For the colors, it's not so clear. So if we highlight, the position and color, you see that for position, it's quite easy to see that, to perceive that trend, whereas color, not so much. So again, why do we care about this? Well, the reason we care about this is that if we wanted to represent these important trends in our data set, we should consider using position length, especially if they're quantitative data, before we consider using color, because it's more difficult to perceive the differences in colors and map that to our underlying quantitative variables.